Okay, good morning. Um, Welcome. First day, day one. No, actually, not gonna count from day one. We'll start from day 13 because it's a countdown. So today is day 13 before the exam. The exam is on May 24th. It's a Friday. You hearing me clearly? All right. So I was having a lot of technical issues. Still might have, but we start where we are, right? All right, the first thing we want to do is that we'll be covering the section of the syllabus that talk about problem solving. Um, Let me see if I can bring up the syllabus. So we're talking about problem solving. Let me see. And checking it, yeah. So problem solving section, which is one of the areas where most persons seem to have the biggest challenge, okay? And I thought it very wise for us to focus on that area first, right? Get the hardest part out of the way, so we can refine any issues we have early up. All right. So we start by saying that what is problem solving? Problem solving is really everybody have problems, right, Kyle? You have problems that you need to solve on a daily basis, and how we tend to solve problem in a systematic way, which is similar to how you solve problem when you come on to programming, right? So usually you have a problem, right? And when you have a problem, let's say the problem is you need to bring a box outside, right? The box is very heavy, and you need to bring it outside and put it in the car. How are you going to bring the box outside? That is the problem, and you need to solve that problem. So the mere fact that I just told you, the problem is to bring the box outside and put it in the car. You have now defined the problem, which is the first part of problem solving. You have defined the problem. Can you see my screen, right? So the first thing is that you've defined the problem. The problem is you have a big box and you need to bring it outside and put it in the car, right? Now, once you have defined the problem, you need to now figure out how am I going to bring the box outside and put it in the car, right? Am I going to go through the front door? Am I going to take the back door, right? Do I need to take the steps? Do I need to go through the gate? Whatever methods you can use to solve that problem, that is where you will now be proposing solutions. How am I going to bring the box outside? So I know the problem is I need to bring the box outside and put it in a car. And now I need to figure out what are the different ways I can do it and evaluate the solution. Propose and evaluate the solution really is I'm going to list out all the different ways I can get it outside in the car, and based on that, the next step of problem solving would be determine the most efficient way. Right? So you know where the car park in the garage, right? Right? Now you could use the front door and you could use the back door. Which one is the most efficient way in your view? And why is the back door the most efficient way? Because it's closer to the garage. So in just doing that, you have just chose what you have thought to be the most efficient solution. So your solutions were using the back door or use the front door, and you have assessed to say, all right, outside of using the back door, instead of the back door is closer, and that is why you say that it's closer to the garage, and that is why you would now say this is my most efficient solution, right? So just by doing that, you have just selected your most efficient solution. The next thing is of this problem solving step is now to represent the solution as an algorithm. Now, algorithm, we're going to jump to the meaning of what algorithm is. You might not be the first time you're seeing that word. Once you did your SBA, you would have encountered that word, or you've been taught the word in class, right? But an algorithm is really just a step-by-step solution with instruction how to solve a problem. That's all it is. Step-by-step instruction or solution. So we're following the same problem. The problem is we need to bring the box outside the house. So the problem we've defined is that we need to bring the box, put this over here, outside, and put in the garage. Right? That is the problem we're doing. Alright? So we need to know, next step of problem solving is to represent the solution as an algorithm. And we said that algorithm is just simple step-by-step instruction of how you would solve the problem. So just briefly, tell me how would you solve this problem using the back door? How would you solve this problem bringing the box outside and put it in the back door, in the garage, in the car? In the car. It's simple, just you don't have to be elaborate. Just tell me what you do. The first thing, I can help you start. The first thing is to take up the box, right? If it's too heavy, how would you carry it? Right? You open the door. So you say you're going to open the door because your box is heavy, so you can't take up the box, but you can't. So, all right, let me follow your thing. You said that you're going to open the door. Step by step. So you're going to open the door. What else you're going to do? Open the car. What else? What else? Check the box. Check if the box is heavy. Okay. And if it's heavy, what you're going to do? Okay, you're going to get help if it's heavy. All right. Okay. So you're saying, okay, if it's not heavy, if not, you say that you're going to bring it to the car. And then, you say, close the door. And those are your instructions. Those are your instructions, and that's what you call an algorithm. All right, bear with me. Trying to figure out these tools, but bear with me. We want to work with what we have, right? Right? So your instructions are going to be, you're going to open the door, open the car, check if the box is heavy, check the box if it's heavy, and if it's heavy, get help. If not, bring it to the car, close the door. Which door are we closing, the car door or the back door? Right? So, all right. So let's go back over before I deal with the last step part of the problem solving. So first thing we say first step of problem solving is that we need to define the problem. What is the problem you're trying to fix? What is it? So you define the problem. Once you've defined the problem, you're going to propose and evaluate solutions. What are the different ways you can solve the problem, right? And during evaluation, you will now determine what is the most efficient solution. What is the best solution? Out of all of the solutions you've thought about, what is the best solution? Once you've identified the best solution, right? Right? Once you've identified the best solution, the next thing you're going to do is represent that solution as an algorithm. Write it as an algorithm, right? And we've done those steps. We've done those 4 steps, right? So let me put in the, just for visual, just for you to understand and don't forget. So we had the choice where the solutions were use the back door, use back door, let me fix this up here. So tell me if it's confusing here, or you're getting it, or you're understanding what is going on. Remember, the best solution, use the back door or front door. So we have the problem, we have the proposed solutions, and we've chosen our best solution, the most efficient solution out of the choices, and then we have done our instruction, right? You're getting it? Understand so far? Yeah, okay. So the last step, or the last step in the, so we've done these, right? The last step is to test and validate your algorithm. Testing and validating. You're just going to make the algorithm better. That is what it is. So just looking at your instructions, right? I'm looking at it, and I'm saying, all right, is it perfect? We open the door. What door are you opening? Are you opening the back door? The front door? Right? That is what you're testing, you know, so we know that, okay, I'm opening the back door, right? So I'm opening the back door. I'm trying to, hold on. Okay. I'm opening the back door. You open the car. That's the next step. So just imagine you're doing this. What about, how are you going to get to the back door? How are you going to get to the back door? You're going to walk. So you're going to walk to the back door, right? When you reach the back door, you're going to open the back door. Once you open the back door, is the car right there at the door? It's in the garage. So what are you going to do to get to the car? You need to get to the car, right? As you reach the back door after you open it, what am I supposed to do? You're going to walk to the garage, right? And we can do this. This is what we're doing. We're testing the algorithm. We test it, we check it, we fix it. You know? Because when you're giving instructions, and that's the purpose of this algorithm, we were just using a real life example. When you're actually giving the computer instructions, you have to be specific. You have to be concise, right? It's not going to encounter, it's not us human being, when to reach the back door, it's going to naturally know that, okay, I should walk. You have to tell it to walk. So when you're giving the instructions, you have to be clear, right? You have to be concise. And again, that's the beauty of this nice cheat sheet. Here we have it. When we're doing an algorithm, a well-defined algorithm, we need to be precise. We need to be clear. We need to be unambiguous. You know exactly what you're doing. It cannot be unclear. When you give the instructions, nobody can read it and say, okay, but what is, suppose I interpret it as something else. It must be clear, right? The next thing is that it must take finite number of steps, which means it's going to be a set number of steps. It's not going to be steps that, okay, if you're doing it, Kyle, you do it a different way. When I'm doing it, I do it a different way. It has to be the same exact steps, and it must be a set number of steps. A set number of steps. It must be readable, right? Because if you're giving the computer to read it, it must understand what you're doing. I don't need Kyle to come and interpret and tell the computer what he meant to say. It must be exact. It must be clear. It must take a finite number of steps. And it must be readable. And the next thing is that it must end. It must stop. It must have an end. In our algorithm, where did it end? Did it have an end? Yes, it ended when you close the door, the car door. Full stop. Have we solved the problem? The problem is to get the box in the car, right? Now, I'm looking at your algorithm. I could do some more tweaking to it because you did not tell me that you put the box in the car. You realize that? Did the box go in the car? You said that you said that you check the box if it's heavy, get help if it's heavy. If not, bring it to the car. When you brought it to the car, did you put it in the car? So, but your instruction didn't say it. So that's why when you're doing algorithm, that's why I'm saying it must be clear. It must be clear. And when you're testing and validating whether you have solved the problem. Have you solved the problem that you set out to fix? It must be clear. So pay all of those in mind. So what we've just done is that I've told you what the steps are to problem solving, right? I use a different color. So you have the steps of problem solving. We know what a well-defined algorithm is, and we know what an algorithm is, right? And just to be clear, let's go back over what an algorithm is. An algorithm is a set of steps of a solution. That's it, with instruction as how to do something. So it must it must have an action. What actions are you going to take, or instructions you're going to give it? What is the order in which you're going to do the instruction, and when to stop? When you're doing algorithm, you're not going to swat this information, Kyle. You're not going to swat it, right? You need to understand. Once you understand what you're doing, you don't have to memorize these things. You just think about the example. Think about an example of you solving a problem. And if they ask you a question, okay, what are the steps of problem solving? Okay, think about a problem you're solving. First, I need to tell you what the problem is. Then I need to come up with solutions. Once I've come up with solutions, what is the best solution? I pick out the best solution. And then I write an algorithm for that solution. Then I test and validate it. So you just need to understand, all right? Any questions so far? We're moving speedy, because we only have 13 days. We only have 13 days. Forgive my scribbling. 13 days left. You don't understand? Don't understand you? Okay. All right. So we move into the next part. We talk about algorithm, right? We spoke about algorithm. The next thing we need to talk about is there are two types of algorithm. Two types. The two types are pseudocode, which is going to be very familiar, which is basically English type words. Words, you're just saying words. That is what we just did right here. In essence, similar, we're going to say in words and phrasings that we can now simply convert to programming. So when you did your SBA, you did something similar. You did a pseudocode. The choices were you could do a pseudocode or a flowchart. So the first one type of algorithm is a pseudocode, which is English type words and phrases that are clear to be converted in a programming language. So you can just read it and then write the appropriate syntax or in the language that you're using. For flowchart now, it's another type of algorithm. Flowcharts uses symbols, right? They use symbols to represent inputs, processing, and output of data, right? So you can clearly see the difference. I saw where in one of the feedback is that students tend to confuse pseudocode and flowchart. I'm not sure why, but the difference should be clear, right? So the difference should be clear. One looks like English. No symbols are in the English type pseudocode. Whereas in flowchart, you're going to see symbols. You're going to see things like, let me show you what a flowchart looks like. All right, we're back again, right? So I found a flowchart. There's a flowchart. So it should be very clear what a flowchart looks like. You're going to see symbols, right? Each symbol have a certain representation, which we'll go through to see what they mean. But once you see a flowchart, you should know what a flowchart is. So if they ask you to draw a flowchart, you know you're going to be doing symbols. You won't be using you'll be using words, yes, but you will incorporate symbols. Whereas an algorithm is going to be more English-like. All right? Clear as mud or clear as water? Is that clear as mud or water? Which is it? I'm saying that when you're getting the exam, one of the problems I saw that it reported is that students tend to confuse flowchart and pseudocode, right? So I am telling you it needs to be clear what the difference is. We're saying a pseudocode is English type words and phrases that can be converted into programming code, whereas a flowchart using symbols, and each of the symbols means something. The symbols represent what the inputs are, the processing, the outputs, and you soon go back to that part to see what the different symbols link to. So I showed you an example what a flowchart is, right? You can see the screen, right? So if they ask you to do a pseudocode, what would it be? What would a pseudocode be? English-like terms. And if they ask you to do a flowchart, it would look something like this on your screen, right? Something like this. This is a flowchart. What is this? A low chart. Right. Moving right along, right along. The next thing we're looking at are variables. Right? This is just a revision. Any specific detail or more in-depth information you want, you go back to the textbook and you fish that out, right? Before we move to variables, the next thing we're going to look at is IPO model. An IPO model simply represents what the inputs are, what processes are included, and what the outputs are. Inputs are going to be what values you're going to store, and processing is what calculations you're going to perform, you know, what processing you're going to do, and output is going to be what results you're going to give to the user, right? Remember, we're talking about computing. So we see this word variables. What exactly are variables? What are they talking about? It wouldn't be the first time you've seen variables. You had to do it in your SBA, right? Now, variables are named area of computer memory used to store values. So just think about you naming a box. You have a box and you say, okay, I'm going to put the number of apples I have in that box. And that is where I would store how many apples I have. That is what a variable is. It's like a location you're going to put a value inside of, right? It is usually when you're creating variables, right? You want to write variables that give them name that are sensible, which are short. You can look at it and know what it does. You don't have to guess. What are you putting in this value? It needs to make sense, right? Remember, we said we're using English type words. You need to make sense, because yes, the computer is going to read it, but you are the one typing it. You are the one. The programmer is the one writing this code. So you must be able to go back through and read it. What is it saying? What did I use it for? So the names must be short and simple and sensible. Look at this example. We see that this is the variable num. Obviously, from the name, it's a number, right? And the variable num is storing the value 44. That's all that is saying. So the variable called num has the value 44. And just by doing this syntax, writing this line, you are initializing and assigning a value to a variable. So if I use the word and say assign, create a variable, Kyle, you're here with me? If I say create a variable for the number of birds you have at home, what would you call your variable? You're nothing fancy. What would you call your variable? What would you call a variable? And let me give you an example. Let me do that example and give another one. So I would call it bird count, right? So I would call my variable bird count. Bird count. And inside that variable, I would store 1 because I only have one bird, right? I would call it 1 because I only have one bird. So my question to you is, what would you know if I give you another example? Give you another example. Give me a variable that will tell me the number of books you have or the number of subjects you do on Monday. What would you call a variable? Number of subjects you have on Monday. What would you call it? Subjects. And you would assign it 4. Right? So that is all the variable is. It's just a named area, and we give it a value by, we call that process of giving it a value initialization. We call that process initialization. So initialize, or you are assigning a value to the variable. That is it. Now, when you have variables, you have basically two categories of variable, right? You have variables that will, when you're writing, we're talking about a algorithm now. So you have variables that will have values that can change during the steps, during the instructions that you're executing, during the steps that you're taking. You have values that can change. You might start and it start with 0, and by you reaching the middle of it, it's at 2. At the end, it's at 3. So that variable can change. The value can change during the algorithm. But you also have another type of variable that you call constants. And those values can never change. Once you set the value at the beginning of the algorithm, it will never change. So this example I have here on the cheat sheet is called, the variable name is called what? Pi. You know pi? You do math, right? Pi is a value, a set value. And pi is 3.14. So if I'm doing an algorithm that I'm going to use that value in, I just create a variable and set it as a constant and assign 3.14 to it. And anytime I want to use that value, I use pi, and it will never change. It will always be the same. So you have constants. They will never change, Kyle, never change. Constants value never changes during the algorithm. Moving right along. Assigned value can be calculated. So we said that we can assign a value or initialize a variable by just giving it a value. Your example, your subjects, you assigned 4. 4 subjects you do on Monday, right? Now, this example of assigning a value to a variable, the variable here is called total. And I'm going to assign a value by doing a calculation. So I'm adding number 1 plus number 2 will tell me the value of total. That is me assigning a value to it by doing a calculation. So that's another way that you can assign a value to a variable. Full stop. Any questions? Okay, right? What we were saying is that's it for variables. That's in essence the key things you need to remember about variables. As I said, any nitty-gritty, any more additional information you think you need and you're not understanding this fully, you can ask me, yes, and you can also consult your textbook. But you just need to know what is a variable, understand what it is, what are the different types of variables really. You have the variables that you can just that the value can change during the algorithm. You have constants that will never change, never change. I keep on stressing that word never. And you have ways that you can assign values. And another way of saying assigning is initializing as well. The initializing is at the beginning. You can initialize at the beginning. You can assign values to the variables, right? By just giving it a value. You can also perform a calculation and assign it to the values, to the variables. And that's it. That's the most essential information about variables. So see, we're moving right along. Any questions before I move to the next section? Any questions? All right, moving on. And we're back. So now we're moving right along. Data types. So we spoke about variables, right? Spoke about variables, right? Now we're going to talk about data types. Now, variables have data types. Usually you have a variable, you have to give it a type, and really all the data type is what telling you what you're going to store in that variable, right? You usually declare at the start to reduce errors, so you declare it at the start. So if you remember when you're doing the SBA again, I'll call that again, right? When you were trying to convert your algorithm back to code, you would have encountered some errors because you wouldn't have given your variable types, and you have to fix those things. So data types is really telling you what kind of data you're going to put in the variable. So the different data types are going to be, we have Boolean. That is really just true or false. True or false. So you're going to store in that variable true or false. So if you want a variable to tell you we'll check whether it's true or false, you declare it as you set it as a variable. And when we set it as a variable, another word is declaration. I am starting my algorithm. I'm going to tell you upfront what the variables are going to be. What are they going to be? Right? So that is called declaration. So I'm going to declare and tell you what my variables are going to be. So this variable here is called check, and it is going to be a Boolean, which is going to be true or false. The next variable here is count, and what type of variable is going to be. Remember, I needed to be engaged. It is going to be a what? This is the variable count, and what is the variable? The variable, it is going to be an integer. An integer. An integer is basically numbers. That's all what an integer is. Numbers. Give me a second, hold on. I'm back. So an integer is going to be, can store whole numbers. Whole numbers. No points or no anything else, just whole numbers. So it's going to be things like 0, 1, 2, 3, 4, 5, 6. That is what an integer is, right? Whole numbers, 0, 1, 2, 3, and so on, right? Following so far? Right, good. A float now. We said this variable called pay is a float. Why I put real? Because I've seen in some of the questions where they use the data type real, so you just need to recognize when you see the word real, it is simply the same thing as a float, right? So a float now, or float or real, put it the other way around. I see float or real can store any number including decimals. So you're talking about decimals, so like 3.245, you know, 1.5. That is what you would put float in a reel. Next thing is a character. That's another data type. It stores a single keyboard character. So characters can be numbers, they can be letters, right? Usually you put them in quotation mark, a single quote. Can be letters. It can be some of the symbols that you have on the keyboard, right? That's a character. So character store single keyboard symbols. So the next thing is string or text. You just need to recognize them. So when you see them, if they use any one of them, you know what they're talking about. A string is just a series of characters. So I can write a word. The word is, that is what you would call this would be a string. So you see those? So we have Boolean, we have integer, we have real or float, we have character, and we have string. Those are the data types. And all I did here is to show you an example of initializing those variables. Initializing, again, you do it at the beginning, and it's another way of assigning a value to the variable. So the count variable here was assigned the value 2. The variable pay was assigned the value 202.2 because it's a decimal number. And we say pay here is a real or float. And you have the value. Value is a character T, and the string name is Sarah. Clear as mud? Clear as water? Crystal clear? Clear as ice. Alright, I'll take it. The ice not really clear still enough. You take up the ice, you can't really see through it. Not all of them, but move it right along. Input, output. Before we spoke about the IPO chart, where you capture input, processing, and output. Now we're talking about algorithms. So in algorithms, you must have inputs and you must have outputs. And those value of an input are stored in a variable. You store them in variables. So this example here, input values are stored in variables. This is a command. These are keywords. So once you see you're doing a pseudo code, and we said pseudo code is English-like terms, you're going to see terms like this: input or read. Once you see input or read, that means it's you're getting an input value from the user. And hours here is the variable. So you're going to get the hours from the user and store it in this value, in this variable called hours. Capish? When we talk about output, we're talking about the results for the user or from the user. So if you see any one of these key terms, write, print, output, display, once you see any one of those key terms, it means it's an output. You just need to be familiar with the term. So you're going to see input or read, and that means that's an input. You're going to see things like write, print, output, display, and those are an output. Outputting the value, displaying the value. Now you can also prompt the user. Usually when you're asking for input, you prompt the user. You tell them what you want them to enter. Right? So this example, you're telling them that I want you to enter the hours worked. So you would output to them, enter hours worked. That is what they're going to see, and they know that, okay, I need to enter a number. So I write in the hours, and read is where you accept the input from the user. Any questions? That's input and output. Any questions? All right, sir, we're moving right along. We're back. We've gone more than half an hour so far, and I hope you realize the beauty of this cheat sheet. Okay, you want me to do an example of an IPO? All right. We're gonna get to that. So you want me to pause right here and do IPO? We can do that, you know, before we move to um operators. All right, simplify now. I found a IPO question, right? Sorry. You are given the problem of finding the average temperature by using maximum and minimum temperature readings. You then calculate and output the average temperature, and they show you how average temperature, this is division, it looks, this is division, right? So they show you how you calculate average temperature, right? All right. So IPO chart, we're going to have, I'm trying to fix this word, as this is not IPO. This is not input. All right, so the IPO chart must have input, processing, and output. Those three columns. You're following? So we're saying that now, what is going to be the input? So the problem is you're given the problem to find the average temperature by using maximum and minimum temperature reading. Right? So based on that, what will be your inputs? What are the things that you need to be able to find the average? They gave you a formula. They tell you that to calculate and output the average temperature, they say it's max temp plus min temp divided by 2. So based on this, what are your inputs? What do you think your inputs are? What do you think your inputs are? What information do you need to find the average? You need the temperature readings, right? Yes. So to be more specific, based on this example, one of the temperature readings that you're going to need is the max temp. The max temp. What's another input that you're going to need? What's another input you're going to need? So you need the maximum temperature, and you're going to also need what? Look at the question, the minimum temperature, right? So those inputs, once you have that input, you put that under the input column. What should be clear now, what after you get the maximum and minimum, what you need to calculate, you need to find the average, correct? And we say processing is, so go back. Processing is the values are calculations. So under processing, what calculation would you be performing in this? What calculation? It says you are finding the average temperature by using maximum and minimum temperature readings. You then calculate and output the average temperature. So what are you calculating in this? Right. So that is what you'll be calculating. So they actually told you, what it is in this example. So you're going to be calculating, you're performing this calculation, and that is what you would put underneath your processing. You're going to calculate the average. You're going to calculate this, right? Now, what is the output? Output, what are you going to present? What are they asking you? And the word is even there. They use the word in this example. It's very simple. The word is, they tell you what the output is. What is going to be your output in this example? Right, you're going to output the average temperature. We need to store that in a variable, right? So we're going to call the variable average temp. That's it. That's it, you know. You want to try one more? All right. Let's try this one. This one is, you're going to read a number, add 10% and output the results. All right, we're back. We're going to just work out this question and then we'll take our break. We deserve it. Been more than 40 minutes. So, yes. So now this question says, read a number. Let me draw up my IPO chart again. I'm going to draw up my IPO chart. So, drawing up my IPO chart. Hold up. See if you can tell me what to put there. See if you can try, tell me what to put there. What are the inputs? You said that you're going to read. Read, remember that keyword, read. So you're going to read a number, then you're going to add 10% and output the results. So what is going to be the input? All right, so you're going to call that variable number. That's what you're going to call it. So you're going to call it number. Okay. And what is going to be your processing? What calculation are you going to be performing? What is the calculation? Read a number, add 10%, and output the results. What is the processing? What calculation are you performing? Add 10%. You're going to add 10% to the number. So the calculation that you will be performing is that you're going to add 10% to the number. So let's put that in. All right, so math, this is math again, number, and you're going to add 10% to the number. So the formula for adding 10% to the number is going to be you finding 10%. So 10%, you can represent 10% in decimal, 0.1, right? And you don't forget your brackets. Don't forget your brackets. Don't forget your brackets. Right? That's one way of doing it. You're adding 10% to the number. Another way you could do it. And this is an OR situation, so you don't have both of them underneath it. So you see, you have to remember math, right? So they might give you things like this in words, and you just have to write what the calculation is going to be. So you have to remember math, Another way to find 10% of a number is really multiplying the number by 1.1. That's another way of finding 10%, but that's a little math for you. You're adding 10% to a number. That's a little math to it for you. So these are choices. It's going to be this one or the other one. What is going to be your output? Tell me your output. What is going to be your output? So what you could do, right? The output is going to be what? They said output the result. So what you could have done is name this calculation, create a variable to store the calculation in, right? Create a variable to store the calculation in, and that would be result. So if you were to now output the result, what would it be? Result. Yeah? So this is what you're processing. What would be your output? What you're going to print to the user? It says read a number, add 10%, and output the result. You can't get any clearer than this. This is pretty straightforward. Output the results. So what you're going to show to the user after you've accepted the number, read the number, you have processed the number, you're going to put the results. So you're going to print the results. So the result is going to be, the output is going to be result. That's it. Probably if you had a print statement. Now we get more into that when you're looking at an actual pseudocode, right? Or even a flowchart, and they ask you to do an IPO chart based on that. But this is basically what the IPO chart looks like, right? You have an input column, a processing column, and an output. How is that? Any questions? Okay, so we are going to take our break right now. We've been at this for quite some time. We take the break and we'll come back and see if we have actually learned anything. All right?